Good day! We're going to discuss how to solve Pythagorean theorem. But first, what is Pythagorean theorem?
In the right triangle, the square of the hypotenuse, which is the longest side, is equal to the sum of the squares of the other two sides, or the two legs. Now, let's have an example. To find the value of c, we will use the formula of Pythagorean theorem, which is a squared plus b squared is equal to c squared, where a and b are the two legs of the triangle and c is the hypotenuse. Since the length of leg A is 15 and the length of leg B is 20, we can write this as 15 squared plus 20 squared is equal to c squared. 15 squared is simply 15 times 15, which is 225, plus 20 squared is simply 20 times 20, which is 400, equals to c squared. 225 plus 400 is equal to 625, and c squared. Since c is being squared, we must take the square root of c squared and also the square root of 625. The square root of 625 is 25 and the square root of c squared is c. So, the hypotenuse is equal to 25.
What if the length of leg B is missing? So, to find the value of length B, we will use the formula c squared minus a squared equals to b squared. Since c is 17, therefore 17 squared. A is 14 squared equals to b squared. 17 times 17 is 289 minus 14 times 14 is equals to 196 equals to b squared. You simply subtract the length of c and a. 289 minus 196 is equal to 93. Is equal to b squared. Since b is being squared, we must put square root on both sides. The square root of 93 is still square root of 93, and square root of b squared is b. So, the value of b is square root of 93.
What if the length of leg A is missing? In finding the length of leg A, we will use the formula c squared minus b squared is equal to a squared, where c is equal to 25 and b is equal to 9 and a squared. 25 squared is 625 minus 9 squared is 81 squared. 625 minus 81 is 544. It is equal to a squared. Since a is being squared, we must get the square root of both sides. Since 544 is not a perfect square, therefore, we should get the factors of 544, which are 16 and 34. The square root of a squared is a. 16 is a perfect square, so we will get the square root of it, which is 4. And the remaining number will be put inside the radical sign. So the value of leg A is 4, the square root of 34.
In this figure, there are two triangles, which is triangle ABC and triangle BCD. And there are also two missing values, which is the line segment BD and line segment BC. And for you to be able to get the line segment of BD, you should get the value of line segment BC first. And for you to do that, we will use the formula line segment BC squared equals to line segment AB squared minus line segment AC squared. Line segment AB is equal to 20 squared. AC is 16. Twenty times 20 is equals to 400, and 16 times 16 equals to 256. Minus 256 is equal to 144. Since 144 is a perfect square, we will get the square root of both sides. The square root of 144 is equals to 12. So, line segment BC is equals to 12. Since we got the value of BC, therefore, we will proceed to the next step, which is finding the value of line segment BD. And for you to do that, we will use the formula line segment BD squared is equal to line segment DC squared minus line segment BC squared. DC squared is equals to 24. So, 24 squared. BC is 12 squared. 24 times 24 is equal to 576. And 12 times 12 is 144. .576 minus 144 is 432. Since 432 is not a perfect square, we will put square root on both. The square root of 1 BD squared will be BD, line segment BD. And the factors of 432 is 144 times 3. The square root of 144 is 12, and the other factor will still remain in the radical sign. So, line segment BD will be 12 square root of 3.